This is section 7.04 of the Unit 7 notes, periodic functions. Today I am, as in you are the student, identifying period and amplitude so that I can determine if a graph or data set is periodic and calculate the period and amplitude. I will know I have it when I can solve problems involving real-world situations that exhibit periodic behavior. Specific TEKS we're looking at for today's lesson is 7a, use trigonometric ratios and functions available through technology to model periodic behavior in art and music, and 7c, use geometric transformations, proportions, and periodic motion to describe mathematical patterns and structure in music. What is a periodic function? Basically, a periodic function is a function, a graph, a line that you see on an XY coordinate plane, or maybe some others like a 3D model, whatever. Periodic function is a graph, a function that repeats its values over and over and over and over again. So for example, if one of those values is 5, it'll go up and down in value, but it will come back to that 5 eventually. So it'll just keep going up and down and repeat the same values over and over and over again. And it'll repeat in intervals or in periods. After maybe 5 seconds, it'll go back to the same value. After 10 seconds, 20 seconds, minutes, hours, days, whatever. It might not even involve time. It could be after a certain amount of measurements, that pattern will repeat over and over again. That is what we call a periodic function. Now, periodic functions appear in many different areas of the world. One of the ways you can see a periodic function is through a wave. If you go out to the ocean or go to a body of water and you observe a motion, a wave in the water, you will notice that wave tends to repeat itself. That is a periodic function. If you were to take the measurement of the heights of the waves after a certain amount of time, you will notice that those waves' heights will repeat itself. So here's a GIF of a actual wave, but then here's an animation GIF of a wave. This little dot right here, marked in yellow out of a sea of blue, and then this one right here in the middle. Notice how that wave is causing the dot to repeat its motion, repeat its height over and over and over again. So that's, again, what we call a periodic function. Some other things you may see are different measurements, like, for example, our heartbeats often show a periodic behavior. Every single heartbeat has a certain rise and fall that we can measure. And then other measurements, like when you go to the hospital and you see that little monitor that measures a whole bunch of different things. Like, for example, one of them is heartbeat. The 2 is the respiratory rate. Some others are like CO2 levels, carbon dioxide levels. And I believe these last 2 are blood pressure. Those also exhibit periodic behaviors. Other things that exhibit periodic behaviors are things like the moon, the sun, the planets. They all go through a periodic behavior of rotations around the sun. Tires, for example. Tires often have a periodic behavior of where one end of the tire is going to be compared to the other. And there's many more different representations of periodic behavior. Roller coasters, Ferris wheels, you name it. You could probably search it up on Google. But periodic behaviors are, again, basically things that repeat over and over and over again after a certain amount of time, or a certain amount of measurement of something, whatever. Okay? So some things that we're going to be looking at in a periodic function are period and amplitude. What is period? The period is the distance from one peak to the next matching peak. Because, like I said, a periodic function is basically a line that repeats its measurements over and over and over again. And so you will get, on a graph, repeating values. The segment from one part of the graph to its next part, where it starts to repeat itself, that measurement is called the period. You can measure that out, and you can determine what the next peak will be, and so on and so forth, because everything repeats. So that is measuring the x value, the x length. from one end to the other. Amplitude is the distance between the peak and the midline. So it's measuring the y value of the graph. Now again, notice how it said midline. Midline is the middle part between the peak and the valley. It's not always shown in the graph, and so we have a ways of calculating that by taking half of the maximum value subtracted by the minimum value. The midline is the middle portion of the graph. It is the horizontal line that's halfway between the maximum and the minimum values. Again, it's not always present, so in order to calculate that, we can take the amplitude, find the amplitude, and then measure halfway down the peak or halfway up the valley to find that midline of the periodic function. So here's an example of a period in amplitude. We have a graph. We have the x-axis as t in minutes. So t represents the x-axis in this case, so I'm going to call it the t-axis. Again, this is the amount of minutes that has passed. And then the height in feet right here is the y-axis, which we will call h. Notice the midline right here, the middle value, that will split the graph in half from the top to the bottom. We also have things like amplitude and period that we're going to calculate. So for example, let's say we want to calculate what the period is from one end to the other. There's going to be different ways that we can go about it. One of those ways is through the peaks, where they repeat itself. So for example, this peak right here, this x value, or in this case the t value, is about 50. So again, we're looking at just this value right here is 50. And then this value right here will be about 30. So to find the period, the amount of time it takes for one part of the graph to repeat itself to the other, from one peak to the other, we subtract these two. 50 minus 30 is equal to 20, which means it takes 20 minutes for this graph, according to its labels, 20 minutes for it to start repeating itself. And you don't have to just do it at the peaks. You can do it at the midlines. So in this example, this value right here is at 45. So again, this value right here is at 45. And then this value right here is about 25. Let's subtract those two to figure out what the period is. 45 minus 25 will be, 4 minus 2 is 2, 5 minus 5 is 0, so again it's 20. You can do it over here on these two peaks as well. Okay, this peak, let's make sure it's a nice one, okay, which is a 70. I mean nice as in nice number. So it's about 70. And then this one right here is about 50. Let's subtract these two. 70 minus 50 is again also equal to 20. So again, you can find it anywhere where it starts to repeat itself. But the catch is you have to make sure you get to the exact same point, or else you won't be actually calculating the period. So you can't go from 70 to 30 and get the period. It has to be the next matching point in order for it to actually be calculated properly. Okay, so again, this point right here can only be calculated with this one, and so on and so forth. So that's how you calculate the period of a periodic function. Okay, amplitude. Now, if you can easily calculate the amplitude, just measure from the midline all the way to the height, to the highest or to the lowest point, and you will get your amplitude, which will be, in this case, from 250 to 500. That's about 250. Let's say we don't have that information, though. Instead, we can only get the highest point and the lowest point. Now, in this case, we're going to be using the y values. Let me use a different color here. So we're going to be using the y values of these of the peaks and the valleys, which for this one it's going to be 500, the h, and then for this one it's going to be 0. So the amplitude is half the distance between the peak and the valley, and the middle, the bottom part. So we're going to subtract that distance, 500 minus 0, and then we're going to take half of it. Okay, so half of 500 is basically 250. If you want to plug it into the calculator, I'll show y'all using Desmos. 1/2 times 500 minus 0. And we get 250, which again is from the midpoint, the midline to the top, or the midline to the bottom. Both of these values are 250. And that is how you calculate amplitude. Okay, now for you try number 1, what is the amplitude of the function? And again, amplitude is half of the max value minus the minimum value. So find the maximum, find the minimum, make sure you're using the y values, not anything else, subtract the two, and then take half of it, and you'll get your final answer. Now notice how this graph has some negative numbers, so take that into account whenever you plug it in and then get your answer. Okay, so if you would like, if you're on ClassKit, go ahead and pause the video, fill this out on your own, and then you can check your answers right here below, see if you went about this in the correct manner. Otherwise, I'm going to continue on and show y'all how to do this. So to find the amplitude, we need the maximums. It doesn't matter which peak because they all repeat itself, so I'm just going to choose this one right here and then find the y value, which is 3. So this maximum is 3. And then the minimum right here is -2. So I'm going to subtract the 2. 3 minus -2, which will be +2, which is 5. And then half of 5 is about 2.5. So the distance from here to the midline, wherever that midline is about 2.5. Now I'm going to show you all using Desmos. 1/2 of 3 minus -2 is 2.5. Meaning if I want to get to the midline, I'm going to have to go 1, 2.5 to create that midline. So about right here. And change the color. In order for the distance to be 2.5 up and then 2.5 below. And there we go. That's it for you try number 1. Okay, some more practice with period here, except now we're going to be using some different values. This symbol that you're seeing right here, this is pi. Pi is the same thing as 3.14. We use the symbol pi because it is an infinitesimal, meaning it's an infinite decimal. It will never stop repeating itself. So this number is significant in geometry. That's all we need. That's all we really need to know. It's significant in circles. I believe it's the circumference divided by the diameter. Yes, it is circumference divided by the diameter of a circle. Okay, so you find pi by taking the measurement of the circle on the outside, the circumference, and then divided by the diameter, and you will get the number pi. So for our purposes for this lesson, we're just going to be think of it as a symbol that represents a number, 3.14. So now, to find the period of this, we need to make sure to label where that period is located from one peak to the other, or Like I said, it could be from one middle part to the other where it starts to repeat itself, or it could be the valleys where they start to repeat itself. As long as you're going for the from one repeating part to the other, doesn't matter too much. However, the graph may dictate which may be easier to calculate it based on the information given. Okay, so just keep that in mind. Now, from one side to the other, I notice that this side right here, this peak, is 5 pi. So we have 5 pi's, basically. Try not to get confused with this this number right here. We just have 5 pi's. Over here, we have 1 pi. So to find out what the period is, 5 pi minus 1 pi is equal to 4 pi. And again, this is just a number. Basically, this is saying 4 times pi. So 4 times 3.14, which will be about 12 point something. Sometimes we like to keep it in terms of pi so that it is an exact number instead of a rounded number like we have right here. But anyways, this is it for period in terms of this problem. Okay, now here's a U-try number 2. What is the period of this problem? Go ahead and go through the steps. Use the tools if you need to kind of help you determine where the period is. And then subtract the 2 x values that you found and get your answer. So if you're doing this on ClassKit, go ahead and pause the video. Try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, now there's going to be multiple ways of doing this. I'm going to show y'all one way, and then I'm going to reveal all the others. So one of the ways we can do this is by going from peak to peak. That will be our period. Okay, one side of the peak, the right side is 2 pi. The left side is just 1 pi. So I'm simply going to subtract the 2. 2 pi minus 1 pi is equal to 1 pi. And that's it. That's my period. Okay, now there are multiple ways of doing this. Okay, this is just the one that I revealed, but you could have taken 3 over 2 minus 3 over 2 pi minus pi over 2, and you're going to get back pi. You could have used 3 pi minus 2 pi, and you will get back pi as well. So there are multiple ways of getting this answer right, not just the one that I used. But anyways, that's it. That is the final answer for U-try number 2. Sometimes we're not always given a graph to check to see if it's periodic or not. Sometimes we're given a data set. So for a data set with just a few ordered pairs, you can determine if the data set is approximately periodic by looking for patterns in the numbers. And I'm going to show you all 2 ways, one by hand and the other through Desmos. Check to see if a consecutive group of values repeat themselves in a general pattern. So in this example, we're going to check to see if we have a pattern through a consecutive group of values. Okay, we're going to check to see if a consecutive group of values repeat themselves in a general pattern. So for this example, we're going to pretend 16 is the average, is our starting point. From 16 to 30, I notice that there's a positive, it goes up, there's more. With 30 to 8, there's less. 8 to 14, there's more. It goes back to about average. And then with 14, there's more. 28, there's less. 10, there's more. It goes back to average. 15 goes up to more. And then 31, there's less. 31 to 11, there's less. 11 to 14, more, less. So I start to notice every 3, there's a plus minus plus pattern. And then this pattern will continue on and on and on and on. So yes, because I see there is a pattern in the numbers, and again, notice where I'm looking for the pattern It's not on the x values, it's on the y values. If the y values show that there is a pattern that you can repeat over and over and over again, then yes, this is periodic. Now I'm going to skip to another one here. I want to skip ahead to this one. Is this data set periodic? If so, what is the period and the amplitude? So I'm going to go through this by hand. 36, 21, that's a minus. 21 to 44, there's a plus. 15 is a minus. 30 is a plus. 30 to 8 is a minus. 8 to 9 is a plus. 9 to 29 is a plus. 29 to 16 minus, plus, minus, and then plus. Okay? So if I look carefully, I notice that there's a minus plus pattern. So every 2 looks like is getting repeated. However, it starts to fail right here. And then it repeats it again. So at this particular point, no. This data set is not periodic. Now, one way that you could also do this, you could also check, is by plugging these into Desmos. So let me go back to that example that we were looking at right here. And we're going to use Desmos to actually type these into the calculator and check for a pattern. Okay, so I'm going to pause the video and show y'all how to type this into Desmos in a little bit. Okay, so now to type these into Desmos, you're going to go to the first line. You're going to click the plus symbol, create a table, and you're going to enter all the x values and the y values into that table. 1, 2, 3, 4, 5, all the way up to 12. And then the y values, enter those as well. And then when you get to your graph, you can zoom in and out wherever you want. You could also set the parameters here if you go to the wrench tool. For the x values, I want to go from, let's say, -1 to about 20. And then for the y values, I notice that my lowest is around 8. So I will put this at 5. And then for the highest, I will put this at around 40. And there we go. Next thing I'm going to do is I'm going to connect the line. So I'm going to click and hold this dot. I'm going to change this to red just so I can see it a little bit better. And then I'm going to click lines so that it creates that pattern that I'm looking for. And you can see, even though these are off by a bit, there is a periodic pattern going on with this graph. So just by visually confirming this, up, down, average, up, down, average, up, down, average, and so on, yes, this graph is periodic. And just like you see here, all these points that are located on the graph, there is a periodic pattern going on. Going back to that example where this was not periodic, I do have the graph here in the right behind this image. You'll notice that it does have a general up and down pattern, but it's not very consistent. Notice how at one particular point it just stops, and then it continues the pattern again. And so no, this is not periodic because it needs to follow the same down, up pattern all the way throughout. And at this particular point, it did not. So no, this is not a periodic function based on the Desmos calculator. If you were to enter all this in the same way we did with the previous problem. And if you're on ClassKick, there is a slide 26, where I have the Desmos calculator linked. So if you would like to use it, there it is. Otherwise, just go to desmos.com and find a calculator there. We're mostly using the Texas state, the STAR test version of the Desmos calculator. So search up star test Desmos, star version Desmos, and you'll see it there. Okay, but moving on. Now, if we're going to move on to the next part of the question. We went through all of this to determine that yes, this function is periodic. Well, since it's periodic, now we can find out whether it has a period, or what the period will be, and what the amplitude will be. So let's go over here. We can do this one of two ways, either by hand or by through Desmos calculator. So to find the period, it's the distance from one peak to the next. So the part where it starts to repeat, notice how over here at the more part, this one right here is 30, and then the next more part is between 14 and 28. So the right side of that more, the right side of this repeating pattern, 30 and 28 is what I'm going to use. So remember the periodic part, the periodic measurement is through the x values. So I'm going to use those x values, 5 minus 2, subtract them, and I'll get my period of 3. Meaning, according to this problem, after 3 days, the pattern will start to repeat itself. And you can use other repeating parts. So like, for example, we can use this, the less part, so this 3 and this 6. 6 minus 3, we will still get 3. We can use this more, which is at 8. And then this more, which is at 11. 11 minus 8 is still 3. Either way, your period is still going to be 3 days. Now, the amplitude is found through the maximum and the minimum. So now we're going to look at the y values. We just looked at the x values. Now we're going to look at the y for the amplitude. Amplitude is half the maximum minus the minimum. So look for the highest part, which is 31. This is the max. Look for the lowest part, the minimum, which is the 8. We're going to take half of that and find our amplitude. So 31 minus 8 times 1/2. I'll put my calculation down here. So 1 divided by 2 times 31 minus 8 is 11.5. And that is our amplitude answer. And remember, amplitude is basically from the midline, how far up or down the graph will go in a repeating pattern. Okay, now if you want to do this through Desmos, you'll enter everything like we did here. And so now I have a comparison of the period and the amplitude here. So the period is from one peak to the next. So take the x values of those peaks. Let me zoom in a little bit more. So take the x values of those peaks, subtract them, 5 minus 2, and you get 3. Take the highest part and the lowest part, use those y values, subtract them, and then take half of it, and you will get them. So again, on Desmos, whoops, let me zoom out a little bit. So if we had all these available, from one peak to the next, 5 minus 2 is 3. And then if you look for the highest and lowest, here's the highest, and then here's the lowest. 31 minus 8, take half of that, and you get 11.5 using your calculators. That's how you can use Desmos instead of doing all that by hand. Whichever way is easier for you, you decide. Okay, so now going through this example, you try number 3. Is the data set periodic? If so, what is the period and amplitude? You could do this one of two ways. Finding the pattern and seeing if the pattern has a repeating, will repeat itself after a certain amount of times, or going through Desmos and checking to see if you can find that pattern there. Okay, and then once you determine yes or no if this is periodic, if there is a pattern, then you will find the amplitude and the period. So at this moment, I would like for y'all to pause the video. If you're in ClassKick, fill everything out and try this on your own. Otherwise, I'm going to continue on and show y'all how to do everything, both by hand and through Desmos. Okay, so to do this by hand, we're going to see if there's a general plus-minus pattern going on. So 102 to 76, that's minus. 76 to 91, that's plus. 91 to 140, that's plus. Then minus, minus, plus, plus, minus, minus, plus, plus. Okay? So, seems like there is a general pattern going on. That I could guess what the next one will be a minus if we were to carry this out past the problem. So, is this periodic? Yes. Alternatively, you could just put this into Desmos and see if there's a general pattern going on. So I went ahead and did that right here. I'm going to use the wrench to change the grid, the X and Y axis. I'm going to put this at -1. And then I'm going to put this up to about 20. It could be 15 if you wanted. For the y-axis, my lowest value looks like is about 74. So I'm going to put this at, let's do 60. And then let's see, the highest value is 140. So I'll put this at 160. Okay, and then again, we're checking to see if there are general patterns. Down, up, up, down, down, up, up, down, down, up, up. And looks like there is. I don't see any part of the graph where visually it does not look periodic. So, yes, according to the graph, it is periodic. So now to find the amplitude or the period, whichever one you want to go, amplitude is easier. We find the highest value, so I'm going to use blue just to distinguish from the rest. Highest value is 140. Lowest value is 74. So here's the max. Here's the min. I'm going to subtract the two. 140 minus 74 divided by 2. So 140, 1 over 2 parentheses 140 minus 74, which will be 33. 33 is the amplitude. Which is essentially the midline. If you want to see the midline on here, you could create an equation. Y equals 33, I believe. Oh, no, I'm sorry. That's wrong. It's not y equals 33. It's 33 from right here. So about 33 down, which is about 107. So y equals 107. It'll create a midline from here, because from 140, it's 33, so 107. And then from 74, you add 33, and that's 107 as well. So there's the midline right there. If you want, if you're interested about that, but that's not really important. That's just the midline. Okay? Now, to find the period, I'm going to use a different color. Just use green here. I'm going to go from one part of the pattern to the other part of the pattern. So let's say I want to go from here. So let's say from 3 after this first plus. So I'm going to go to the next pattern here. This first plus right here is 7. So 7 minus 3 is 4. If you want to do this on Desmos, go from one part of the peak to the other. 8 minus 4 in this case is 4. I think I used 3 and 7. There we go. 7 minus 3 is also 4. So remember, you're using the x values to find the period. As long as you go from one repeating part to the other, it doesn't matter. So let's say, for example, I want to use this part. Then I want to make sure I follow the same pattern or same part of the graph and use the next part. 9 minus 5 is still 4. And that is the period. I believe the next page is showing y'all the answer right here. So yeah, there you go. Different ways to go about doing period. Either way, answer is still going to be 4. And then the amplitude is 33. And then here you go is just more visual examples of what your answer should be. Okay, so now we're going to go through some scenarios, some word problems here that depict a certain thing in the real world that's happening and the graph that it creates, and we're going to answer questions from that graph. So in this example, it's a we try. So if you would like, you can go ahead and pause this video, go through the information, see if you can answer these 3 problems, and then check if you're on Classic, check behind this box right here. But for the most part, I am going to go through this with y'all and walk y'all through it to get y'all to understand what to look for, how to look through the information and get your answers for this problem. So the graph shows a vertical displacement. Vertical displacement meaning the distance from its resting point, either up or down, y in centimeters, that a weight bouncing from a spring would achieve if there were no friction. For a given number of seconds x. So this y value is in centimeters. Let me use a different color here. So again, this y value is in centimeters. The displacement from rest, so here is rest, the midpoint. Let me write a little bit better. From rest, the displacement going up and down from the spring. Okay, and then x is the amount of seconds that this takes. And as you can see, this weight on a spring is creating a periodic function, a periodic graph that repeats over and over and over again. Okay, so now first question: from its highest possible position, how long does it take for the weight to bounce down to its lowest possible position? So we want to figure out from the highest part to the lowest part how long it takes to do that, how many seconds. It's like finding the period, except we're only going halfway instead of from one peak to the other peak. So to find the period that it takes for it to go from the top to the bottom, we take the x value of this, which will be 6, about 6. We take the x value of the lowest for here, which will be 9, and subtract the 2. 9 minus 6, which would equal 3. If you want to do it at a different spot, you could do it at 12, and then you could do it at 15, and we're going to subtract the 2. 15 minus 12 is still equal to 3. So it takes 3 seconds to go from the highest point to the lowest point. What is the weight's maximum displacement? Which is, in other words, find the amplitude. So from rest, what is the displacement to its highest or its lowest? How much does it deviate from its resting position, which is right here at the middle? So we're going to find the amplitude. What is the highest position? What is the highest y value? That is about, let me use a different color here. That is 16 for the highest y value. What is the lowest y value? That's about negative 16 right here. Let me do this. There we go. So to find the amplitude, we're going to subtract the 2 and then take half of it. So 1/2 of 16 minus negative 16 which if you do the math, it'll just be 16, but just to show y'all on the calculator. One over 2 parentheses 16 minus negative 16 will be 16. And so the amplitude for this is 16. And we can tell the resting position is 0, the top is 16, the bottom is 16. So it should be obvious from looking at this graph specifically that the amplitude is 16. But if you want to just plug it into the formula and calculate it, you could do that too. Okay, the final question to this. From its resting position, how long does it take for the weight to bounce in one direction, then the other, and then return back to its resting position? So it's essentially what it's asking is for the period. Find the period to this problem. How long does it take for the bounce to one direction, then the other, and then return to its resting position? So from and to find the period, we're just going to look at the peaks. That's the easiest for us. This case, I'm going to look at the values though. So let's look at the values here and over here. So as long as you go from one part to the other where it starts to repeat, it's fine. Because if you notice, or actually we could do it right here too. Well, no, the resting position is at 0. That's not exactly an accurate value that we can guess what it is. So I would use the whole numbers that the peaks provide here. In this one, 3 is one of those. And then in this one, 9 is the other. So to find the period, 9 minus 3 is equal to 6. And so it takes 6 seconds to go from one part, from resting position, up, down, and then back to resting position. It takes about 6 seconds for it to complete a full wave. You can do it at other parts too, 15 minus 9, 12 minus 6, etc. But we only need to do this once. And then you can move the box to check all these different things, but there it is. And that's it for We Try number 5. I got one more to do for y'all. We're going to go to this next page here. So now, in this scenario, we have a tire. We have an air valve that's continuously going up and down, and so on. Okay? So now to the word problem. The graph shows the height of the tire's air valve, y, so this is the height in inches, above or below the center of the tire. So here is the center of the tire. Because if we notice, it goes to 10 and negative 10, so right here in the middle is the center. For a given number of seconds, x, so x is seconds. As you can see, that air valve is going up and down and creating a periodic function. Okay, so if at this point, if you want to try and do this on your own, you go ahead and pause the video and answer these questions based on the graph given and other information. Otherwise, I'm going to continue on to show y'all how to do each of these. Okay. How many degrees does the valve move per second? So this is going to take a little bit of thinking here. How many degrees is the valve traveling for one full rotation? Well, it's traveling in a circle. How many degrees are in a circle? 360 degrees. Okay, so now how many degrees does the valve move per second? So how many seconds does it take to go for one full rotation? Well, think about it. It starts at resting. The air valve goes down and then up and then back to its resting position. So it takes about 3 seconds to go 360 degrees. Okay? So that's the period. The period is then going to divide into the degrees to figure out how many degrees it's traveling per second. So what we're going to do is 360 divided by 3, which we will get 120 degrees. There it is. So 360 divided by 3, 120 degrees. That means it's moving at 120 degrees per second. Per second. I should have wrote that right here. Per second. Okay, the second problem. What is the diameter of the tower? So here's another problem we have to think about. That air valve is going up and down the full circle. So at one point it's going to the very top of that tire. At another point it's going to the very bottom of that tire. Looking at the graph, that's the peak and the valley. What are the y values of those peaks and valleys? Well, the y value is 10 for the top, and the valley is -10. Now, to find the diameter, we want the distance from the top to the bottom. But we don't want to find the amplitude, so we're not going to cut it in half. We're just simply going to do one part of the amplitude equation. So instead of doing half of 10 minus -10, the maximum minus the minimum, we're going to take away the 1/2 and just do this part. So what's 10 minus -10? It should be +20. You have 20. So the diameter about is going to be 20 inches. 20 inches. Okay, how many revolutions does the tire make in 2 minutes? So to do this problem, we need to convert 2 minutes to seconds. So how many seconds are in a minute? 60. How many minutes do we have? 2. So we're going to multiply 60 by 2, and we get 120 seconds. So let me do this in a different color. This is 120 seconds. Okay. Now, how many revolutions does a tire make in 2 minutes? Well, we know that after 3 seconds, it makes one entire revolution. So after 3 seconds, it goes a full 360 degree, one revolution. So again, one revolution is equal to 360 degrees. One revolution is after 3 seconds. So in 120, we're going to divide that by 3. So divide 120 by 3, and we should get 40. I'm going to show y'all though. 120 divided by 3, 40. So there's 40 revolutions happening in 2 minutes, because every 3 seconds it goes one revolution. After another 3 seconds, that's 2. So 120 seconds is 2 minutes. 120 divided by 3 is 40 revolutions. And then just to show you all the answers right here, here they are. Let me erase some of this right here. And there we go. All right, that is it for We Try number 6. And that's it for 7.04 notes in general. If y'all have any questions, let me know. Let your teacher know, whoever your teacher is, for this course. If you need to go through any of this again, practice. Go rewatch the part where you're having trouble and just go through the calculations again, over and over again, so that you know what you're supposed to be doing. You're not always going to get this the first time. It sometimes takes multiple tries, hearing it out multiple times before it starts to click. So that's it for this video. If y'all have any questions, just let your teachers know, or if I am your teacher, let me know. Otherwise, I'll see you on the next video. Later.